Hey everyone, and welcome. Today we're going to dive into the really cool geometry of circles. We're going to break down how to measure some of its most important parts, these things called sectors and segments.
I mean, you've probably asked yourself this, right? While looking at a pizza, how much area is in one single slice, not the whole pie? Well, guess what? The math behind that is exactly what we're tackling today.
Okay, but before we can calculate anything, we gotta make sure we're all speaking the same language. So first things first, let's get our key terms straight.
All right, check this out. It's a pretty clear difference. On the one hand, you have the sector. Now, this is your classic pizza slice. It's the whole piece, the cheese, the toppings, and the crust. It's bounded by two lines from the center, the radii, and the crusty bit, which we call an arc. But then you have the segment. Imagine you cut off the pointy tip of your slice with a straight line. That part that's left over, the area between that straight line and the crust, that's the segment.
So let's start with that sector, the whole pizza slice. How do we actually find its area? Well, the great news is we can figure this out by starting with a formula I bet you already know.
Yep, good old pi r squared. We all know it's the area of a full circle. And here's the key idea that makes everything else make sense. A full circle is really just one giant sector, isn't it? One where the angle at the center is a full 360 degrees. Once that clicks, the rest is easy.
Let's just walk through the logic here. It's actually super straightforward. Step 1, a full 360-degree angle gives you the entire area of the circle, pi r squared. Okay, that makes sense. So for step 2, the area for just one of those degrees must be the total area divided by 360. And from there, step 3 is simple. To find the area for any angle you want, we'll just call it theta, you just multiply that little 1-degree area by your angle. See? No magic, just simple logic.
And that leads us right to our final, clean formula. The area of a sector is just the fraction of the circle it represents, that's theta over 360, multiplied by the area of the whole thing. It's a really simple and powerful tool to have.
Excellent! We have totally nailed the sector. Now, what about the segment, that other piece, the one without the pointy tip? Well, let's see how calculating its area is actually just one simple step away from what we've already done.
Here's the big secret. A sector is really made up of two smaller shapes. A triangle made by the two radii and that straight line cut, and the segment itself. Which means, if we want to find the area of just the segment, all we have to do is a little subtraction.
And there it is, as a formula. The area of a segment is simply the area of the sector it's a part of, minus the area of the triangle inside it. That's it. We already know how to find the sector's area, and finding the triangle's area is usually pretty easy too. So we've got all the pieces we need.
Let's really visualize this for a second. First, you calculate the area of the entire slice, the sector. Got it? Okay. Next, you find the area of just that inner triangle. And finally, you just subtract the triangle from the sector. Whatever's left over, that's your segment. It's a beautiful visual way to understand it.
All right, formulas are cool and all, but let's see how this stuff actually works in the real world. We're going to apply what we've learned to a classic geometry problem. So here is our scenario. We've got a square field, a horse tied to one corner, and a rope that's 5 meters long. The big question is, what's the total area of grass that this horse can eat? This is a perfect job for our sector formula.
So let's translate this word problem into math. The rope's length is how far the horse can reach from the corner, which makes it the radius of our circle. So r equals 5 meters. Because the horse is tied to the corner of a square, the angle it can move in is a perfect right angle. So our theta is 90 degrees. This means the grazing area is a quarter circle. In other words, it's a sector.
Now comes the easy part. We just plug our values right into the formula. We have 90 for our angle theta and 5 for our radius r. The whole calculation becomes 90 divided by 360 times pi times 5 squared.
And when we crunch the numbers, we get 19.625 square meters. That's it. That's the exact area of the field the horse can graze. See? This isn't just abstract math. It has real, tangible applications.
Wow, we've covered a lot of ground today, from pizza slices all the way to grazing horses. So let's wrap it all up with a quick summary, a little cheat sheet of the most important formulas to remember.
Here are the key takeaways. We really focused on the area of a sector and the area of a segment. And you'll notice they both rely on that same fraction, theta over 360. And hey, as a little bonus, you can see the formula for the length of an arc here too. Think of that as the length of the pizza crust.
It follows the exact same logic, but it applies it to the circle's circumference, 2 pi r, instead of its area. Pretty neat, huh?
So really, the main idea is that you now have the tools to measure parts of any circle you come across. So from the face of a clock to a bicycle wheel, what parts of your world can you now see and measure in a completely new way?